Okay, this question I want to look at a MyMathLab homework question from sections 11.4 and 11.5. This is question number 37. In this question we're told that we have a box containing 23 transistors, and we're told 8 of those transistors are defective, meaning they don't work. Suppose you reach in to the box and pull out 8 transistors at random. The first question is to find the probability that all are defective. Okay, well, setting up the probability question, then we've got the probability that all are defective. Okay, that's equal to, remember how you do this. Okay, you're going to set up some sort of ratio. Okay, for a uniform sample space, we need only count up the number of favorable outcomes divided by the total number of outcomes. That is, we're going to look at the number of ways you can select 8 defective transistors all over the number of ways you can select 8 transistors. Okay. There's a difference here, right? These are the defective transistors. That's how many favorable outcomes there are. Out of how many ways can you select 8 transistors? That's the total number of outcomes. Okay. So in general, when working with a probability question, it's easier to tackle the denominator. So we look at the number of ways you can select 8 transistors. Okay. Well, notice that each selection, selecting the first transistor, then the second one, those are related events, which means that we're dealing with either a combination or a permutation. Well, then the next question is does the order matter? Okay, and in this case, the order in which we select these transistors out of the bin doesn't matter, so then this is going to be a combination. Okay, so we ask ourselves then, how many objects are we choosing from? In this case, there's a total of 23 objects we're choosing from, and we're looking at how many ways we can choose 8 of those. Okay, we're choosing 8 from amongst 23 when we're dealing with our sample space. Okay. For the numerator, by the same arguments, it's again a combination. Okay. But in this case, we're not looking at how many ways can we select 8 transistors. We're looking at the number of ways we can select 8 defective transistors. So now when we ask ourselves how many objects do we have to choose from, we don't have the entire box of transistors to choose from. We're talking about selecting from amongst the 8 defective transistors. And how many of those will we be choosing? We'll be choosing 8. Okay. Crunching these numbers, well, there's no reason to crunch 8 choose 8 on a calculator. 8 choose 8 or 20 choose 20, whatever that is, will always be 1. Okay. And then crunching the denominator gives us 490,314. Okay, so continuing this problem, now working on the second part. The second part says, we've got the same setup, but it says find the probability that none are defective. So, we're going to look at the probability that none are defective. Okay, the leap that you have to make for this problem, I think part B is a little bit harder than part A. The leap that you have to make is that if you reach into a box and you pull out 8 transistors and none of them are defective, what does this mean? Well, this means that all of them must be working, and that's the leap that you have to make for this problem. That's the probability that all 8 are working. Okay. Well, again, we're setting up a ratio then. We're looking at the ratio of favorable occurrences to the total number of occurrences. So the question is, how many ways can you select them so that all 8 work? So that's the number of ways that you can select 8 working transistors. All over the number of ways that you can select just 8 transistors, your sample space. Okay. Well, the denominator of this problem hasn't changed. We still have a combination. We still have 23 objects we're choosing from, and we're still choosing 8. The original scenario hasn't changed. What has changed, though, is the event that marks a favorable favorable outcome. We're now looking at the number of ways of selecting 8 working transistors. Okay. Well, we weren't told, looking back up at the problem, we weren't told how many transistors are working. We're told that 8 are defective, but since we're given the total number of transistors and 8 don't work, that means that the remaining transistors must work, so we take 23 minus 8. That gives us the total number of working transistors. So coming back down to our ratio, we've got how many ways can you select 8 working transistors? Well, we've got 15 working transistors to choose from, and we're going to be choosing 8. Okay. Crunching these numbers, doing so in a calculator, gives me 6,435 divided by, well, this is going to be the same denominator as is often the case for these problems, 490,314. Okay. Now my math lab wants to make sure that you reduce all of your fractions, so make sure you do so. In this case, I crunched these numbers by dividing, trying to divide various numbers into 490,314 and the numerator, and it came out to be 195 all over 14,858. So again, what made the second question a little more difficult was when they said none are defective, we had to realize that that meant that all 8 selected were in working order. And once we realized that, it came down to the question of counting up our sample space. Okay, our sample space still had 23 objects. We were choosing 8. But now what constituted a favorable event, there were 15 favorable outcomes. That is, any one of those 15 is a favorable outcome, and we're choosing 8 from amongst those.